Hi, so today we will talk about the quadratic function. 9.3, how to complete the square. Okay, so for example, we have x squared plus 5x plus 6 equals to 0. Well, we know that use AC method, we can factor as x plus 3, x plus 2 equals to 0. So in this case, we have, by the zero product rule, we have x plus 3 equals to 0 or x plus 2 equals to 0. So we have either x equals to -3 or x equals to -2. However, not all of the problem they can be factored, such as x squared minus 2x minus 7 equals to 0. So how can we factor this? Well, the only factor combination that -7 have is 1, -7, or 7, -1. No matter what, these two, the sum of these two is not going to equal to -2. So we know that we can factor this equation. Well, but there are two solutions. If we use quadratic formula, we will find out that x is equals to 1 at square root of 2, or 2 times square root of 2, or x equals to 1 minus 2 times square root of 2. We can use quadratic formula, which is x equals to -b positive and negative b squared minus 4ac square root over 2a. Okay, but today I want to introduce you another method. Also can solve that. We don't need to use factor or the quadratic formula. It's called complete the square. So the key to complete square we will change the quadratic into a perfect square. Which we can easily solve with a square root property. Solve. Which we learned last week, square root of property, which means we take square root on both sides. So now let's give you an example. So let's do some review. What is square root of property? If you have an x plus 5 square equals to 18, what you do is you square root both sides. And remember, since this is a even index, that means we have a positive and negative solution. When you square root it, I have positive and negative square root of 18. Okay, square root and square, they clear out. So I have x plus 5 equals to square root of 18 is equals to square root of 9 times square root of 2, which is 3 times square root of 2. So I have a positive and negative 3 times square root of 2. And then what? I subtract 5 on both sides. So x is equals to -5 positive and -3 times square root of 2. Okay. So, now we talked about How do you complete the square? Think about the quadratic function. If a quadratic function is in a form of x squared plus bx plus c, we can complete this perfect square by adding and subtracting, adding b over 2 square and then subtracting b over 2 square to the equation. So why I need to add something and subtract something? Well, that is because if you add a number and subtract the same number, this is equals to 0. That means you're not going to change the value of the function. The second question is why I want to subtracting or adding b over 2 square. Because the first 3 terms, if you remember the perfect trinomial, which is x squared plus 2xy plus y squared is equals to x plus y squared. Okay? Based on that, the first 3 term is equals to x plus b over 2 squared. Now we have a perfect square in here. Because this bx, you can look at as 2 times b over 2x. Whereas, look, this is equivalent to our y value. And then we subtract b over 2 square at c. Okay, that's how you complete the perfect square. Okay, now let's use some example. So we have x squared plus ax plus, let's say, 4. Okay, how do I complete the perfect square? Let's not use 4. Let's use a 4. So we have what? B is equals to 8, C is equals to 4. So we want to add what? B over 2 squared to the function, which is 4 squared. Right? That's B over 2. B is equals to 8. Let's be more detailed. B is equals to 8, right? It's 8 over 2, which is 4 squared, which is you want to add 16 and subtract 16. But you want to keep it this way. You want to keep this form b over 2 squared. So I have x squared at ax add 4 squared and then subtract 4 squared. And then add 4, which is our c. It should remain the same. Okay, so the first 3 terms is equals to x plus 4 squared minus 16 at 4. We simplify the term, what remains. So that is minus 12. So now let's try something that more general. Instead of a 4, what if we use a constant term c? So let's see. But it doesn't matter because what matters is the term b of x, the second term, the first power term. So still b is equals to a. We want to add b over 2 squared to the function, which is 8 over 2 squared, which is 4 squared. So look, I have x squared at, oh, sorry. ax at 4 square subtract 4 square. Because these, you add 16 and subtract 16 is equals to 0 at c, a constant c. So the first 3 terms is equals to x plus 4 square minus 16 plus c. Okay. Now let's try another one. X squared minus 7x plus a constant c. In this case, our b is equals to -7. Don't forget the negative sign. So b over 2 square is equals to what? -7 over 2 square. You can keep it in this way. That's totally okay. So that means I want to add -7 over 2 square and then minus -7 over 2 square plus c. Okay, the first 3 terms is equals to x minus 7 over 2 square, because our b over 2 is -7 over 2, so that our perfect square should be x subtract 7 over 2, and then minus, okay. So you know why I always like fraction, because fraction is easier to calculate. You have -7 over 2 times -7 over 2. That is equals to some positive number, right? So 7 times 7 is equals to 49, and then numerator is equals to 49. Denominator 2 times 2 is equals to 4. So it's 49 over 4. Really fast to calculate that. So that is equals to subtract 49 over 4 at c. Okay, let's do a fraction one. X squared plus 5/3 x at a constant c. Okay, so b is equals to what? Our b is equals to 5/3. So that b over 2 is equals to what? 5/3 times 1/2, which is 5/6. So that means we want to add 5/6 square and then subtract 5/6 square at c. First 3 terms equals to x at 5/6 square subtract. Okay, 5 square 25, 6 square 36, and then add c. Okay, that's how you complete the square. Okay, now let's use it to application. How do we solve the quadratic function? We have 3x squared plus 18x minus 6 equals to 0. Okay, so wait a minute. So our x squared is not, the coefficient is not equal to 1. What should we do now? Well, we can factor the greatest common factor, which is equal to 3. So I have 3 times x squared plus 6x minus 1 equals to 0. You divide by 3 on both sides, so you will have x squared plus 6x minus 1 equals to 0. Okay, so what's next? Well, what can we do in here? We can factor this one. So now we can use our complete square method. So look, these two, b is equals to 6. So b over 2 is equals to 3. Okay, so that means I want to add 3 squared and then subtract 3 squared. Don't forget minus 1 equals to 0. And the first 3 terms is equals to x plus 3 square. We simplified what's remained, which is -9 minus 1 is -10 equals to 0. How do we solve it? Well, you want to isolate the square terms, the terms with power on one side, so that you want to add 10 on both sides. So now what's next? You want to square root on both sides. Okay, when you take square root, what do you need to be careful about? So you should have a positive and negative for the answer. So square root of x plus 3 squared equals to positive and negative square root of 10. And then we have x plus 3 equals to positive and negative square root of 10. So the x is equals to -3 positive and negative square root of 10. Okay, I think I did something wrong. You may already find out. So when you factor the 3 out at beginning, this should equals to 2, not 1. But this is not going to change much about the results because -9 minus 2 is equal to what? 11. So that I have 11, so it should be square root of 11. Okay. Next, again, this one, I want you to solve for x. So the first step is you want to factor out the greatest common factor, which is equals to 2. So I have 2 times x squared plus 10x plus 24. I hope I did this right. Okay, so that we have x squared plus 10x plus 24 equals to 0. So now our b is equals to what? 10. So b over 2 is equals to 5. So that means I want to add 5 squared and then subtract 5 squared in the equation. The first 3 terms is equals to what? The perfect square, which is x plus 5 squared minus 25 at 24, which is equals to 0. So x plus 5 squared minus 1 equals to 0. So x plus 5 squared equals to 1. Again, you square root on both sides. We will have a positive and negative solution. So I have a x plus 5 equals to positive and negative square root of 1. Square root of 1 is equals to what? It's equals to 1. So we have either x equals to positive 1 minus 5 or x equals to -1 minus 5. Because in here you want to subtract 5 on both sides. So our x is equals to -4 or x is equals to -6. Okay, so next do some fractions. So I have x squared minus 3x minus 2 equals to 0. Our b is equal to what? -3. First of all, it's negative and then 3. So b over 2 is equal to -3/2. Okay, you want to add a -3 3/2 square and then subtract -3/2 square minus 2 equals to 0. Okay, first 3 terms equals to x at b over 2, which is x subtract 3 over 2 square. And then minus, it doesn't matter when you square a negative side, you will eventually get a positive. So you have a 9 over 4 subtract 2. Okay, so 2, you can write it as 8 over 4. So now they have a common denominator. So when you subtract it, it should equal to -17 over 4. Now, we add 17 over 4 on both sides. So I have a 17 over 4 on the right side of the equation. And then what? We take square root on both sides. Remember, when we do square roots, we need to have a positive and negative solution. I have x minus 3/2 equals to positive and negative square root of 17 over 4. Okay, so 17 square root of 17 over 4 is equals to square root of 17 over square root of 4. Square root of 4 is equals to 2. Okay, so the solution should be x minus 3/2 equals to positive and negative 17. Oops. Over 2. So be careful about the square root symbol. Look, the first one is including the denominator. So you want to write bigger to including the denominator. When you simplify it, it won't include it in the denominator. So you want to write it smaller. Okay, and then I add 3/2 on both sides. So I have x equals to 3/2 positive and negative square root of 17 over 2. You can merge it together. So x is equals to 3 positive and negative square root of 17 over 2. Okay, so now let's do another one. So now I have 3x squared equals to 2x minus 7. How to do this one? What you can do is you can move all the terms to the left. Or you can, but actually we don't need to move all the terms. All we need is what? 2x, right? Because all we care is b. Eventually, our c, we always moving our c back to this side. Look. In here, or in our previous -1, which is our c, we're moving back to the right side. So maybe we can just left the c onto the right side, and then we subtract 2x on both sides. I have 3x squared minus 2x equals to -7. If we take a look, you will find out that, hey, they don't have a common factor 3. And I don't like the coefficient in front of the leading power, the leading term. So what you would do is you can still factor out the 3. We just have some fractions in our second coefficient, which is 2/3 x equals to -7, right? That still works. It's just fractions. Now we divide by 3 on both sides. I have x squared minus 2/3 x equals to -7 over 3. Maybe that looks better because both sides have fraction. Okay, so our b is equals to -2/3. So b over 2 is equals to -2/6, which is 1/3. -1/3. Okay, so I have we want to add. What you want to do is you want to add. You don't necessarily need to do what our old way, since like -1/3 square and then subtract -1/3 square, right? That's equals to 0. You eventually need to move this term to the right side, right? Because we don't need the negative b/2 square. So what you can do is, well, since something is already on the left side, so why don't we just add b/2, which is our -1/3 square on both sides. So the equation still equals to each other if you add them at the same time, the left side and the right side. Okay. So the left side is equals to what? X subtract 1/3 square equals to, okay, simplify first. That's 1/9. And then I need to find the common factor for the first term by multiply 3 for the top and bottom. I have -21/9 plus 1/9. So I have x minus 1/3 squared equals to -20/9. Okay. Well, now we square root both sides. And we will have a positive and negative solution. We have x minus 1/3 equals to positive and negative square root of 20/9. Oops. Something that don't forget, the negative sign. Why? Because there's a negative sign. You can just think that it's outside negative sign, it's equivalent to the inside negative sign. No, they're different. But if you remember imaginary number I, we know that square root of -1 is equals to I. So we can write the fraction as positive and negative square root of 20/3, because square root of 9 is equal to 3 times I. Okay, now I want to add 1/3 on both sides. So the fraction is equal to 1/3 positive and negative square root of 20I/3. So they have a common denominator. I can combine these two terms together. 3. So that would be the solution. Well, maybe we can simplify the square root of 20. So square root of 20 is equals to what? Square root of 4 times square root of 5. So it's equals to 2 times square root of 5. So the solution in the simplest form should be 2 times square root of 5, 5i, sorry, over 3. Okay, so now let me recap this. So first of all, we want the coefficient in a quadratic function. I'm going to use a green one. We want the x squared plus bx on the one side, c taken on the other side, or either side, doesn't matter because we can move it around. Math is just a science of manipulating the numbers. So you can just move the c around. And we want to construct a perfect square by adding b/2 square on both sides. Oops, I don't have enough space. Oh. And then the first 3 terms, they can form x plus b/2 square equals to whatever on the right side of the equation. during this process, you want to be careful about the sign of b because that would change the solution. Okay, what if we have a in here as our leading coefficient? What you want to do is you want to factor the a out first. So, like what we did in this example, you want to factor out this 3 so that your b is equals to b over a. Look, I have ax squared plus bx equals to c. If you want to factor the a out, you will have b over a times x over c. And then you can divide it a on both sides. You have c over a. Now this is become a b term. You can still add b over 2 on both sides. Okay. And then we use the square root property to solve the function. When we're doing the square root of property, you want to be careful about the positive and negative sign. And when we're doing the square root, we need to be careful about the large square root and the small square root. And you want to simplify the fraction as simplest form as possible. Okay, so that's it for chapter 9.3. I'll see you next time.